Okay, guys, welcome to ICE Education. Yeah. So, okay, question 3. I believe that we all have WhatsApp. Definitely, it's on our WhatsApp. They said in figure Q3, a single mass that can move horizontally in one plane. The mass does not have an elastic or damping element ties to ground. The mass acted on by stiffness K and far f of chi, okay, and then the system has a mass this K this. They say determine the second order differential equation, and then they said if f, okay. Guys, do you guys remember from Math 4 you've done something like this? This is definitely Math 4. Okay, let's just call out here. In this case, we are not writing any equations, we are solving how do you call it? We're gonna solve the response function. Is gonna use Laplace. Determine the differential equation. Okay, let's take it as easy as we can take it. Let's recall what is given to us. Here we go. This is literally Math 4. You are given a system of mass. Oh, this thing is, let me increase, of mass to be 40 kg, like master kg. Cosi for life, Mr. Kotso. And then we have K to be 80 kilonewton meter. And we have C to be 120 ns. Okay, guys, question 1. When they said 3.1, when they say determine the second derivative equation. Guys, this is very, very simple. Look what's the moral of the story here, guys. C, remember, K is the spring. It goes with what? Displacement. C is the spring. It goes with what? Velocity. The mass here, we take it as acceleration. It goes with x dot dot dot. Now, if we want to write in terms of differential equation, it simply means you have mass multiplied by dt. Is it in terms of time? Yes. Square of, is it x? What's the motion here of x? Plus c dy dx dt plus h, because it's h, it's a constant, hk, that's why it's only h, to be equal to the force f of chi. This is 2 marks, Mr. Kotso. Now, how am I able to write this equation like this? Like I said, I'm writing a differential equation. All you have to know which guy is which guy. I don't know if my English is making sense. You know that C, which is the, how do we call it again? The damper, it goes with velocity. Therefore, because the variable is x here, everything will be dx dt here. Now, because m here is like a mass times acceleration, that's the reason why m goes with dx dt square. And remember, this is a constant k, it goes as kx, that's why it's only written 8x here, 80 equal to f of g. This is the differential equation that we are supposed to write, and it is 2 marks. Now, when they said, okay, wait, before I proceed, it's a revision. I need to know if we are all on the same page. Sandile, Andile, Kotso, Mr. Machimba, please, are you with me on this first one first?
I didn't get you there. You were cutting from my side. Can you please repeat?
Okay, I'm gonna repeat, no problem. I said, given all these data here, if you are asked to write a differential equation, the differential equation determine the second order differential equation. the differential equation here, given this value, we can write it straight using the math. How do we call it? You don't need to use Lagrange's here. It's a straight math application. If you want to write the differential equation of this, all you need to know is what is each element and what variable do they go with. If you know that the damper goes with velocity, therefore the variable is dx dt. Because if you differentiate dx dt, you get the velocity x dot. If you know that you have a mass, this mass simply means, remember, when we do the first law of Newton, we say F is equal to mass times acceleration. Because of that, the mass will be going with dx dt square. That's what it means. You differentiate x twice, you get the acceleration. That's one of the reasons why the mass goes with dt square and the damper goes with the x dt. And remember, this one is a spring, it is kx. Since it is a differential equation, it will only be written as h to be equal to f of g. If you use the Lagrange's, you're still gonna come out with the same expression. But you don't need Lagrange here. You can simply substitute the value. And that's one of the reasons why it is 2 marks. Are you with me, Mabuza?
Yes, thank you.
Now you are welcome. Now if you read further, they said if the force parameter f of g m equal to 2 this. Okay, what does this mean? You can simplify this thing here. When they said if the force f of g m is equal to exponential 2 is equal to 2 exponential minus t. Now, what does it mean? To get the differential equation, you have to make sure that this guy is alone. How can you make him alone? It means you have to divide everything because they know for you to write this equation, you have to make sure that this m here disappear. They know that at the end of your differential equation, you will get to this. So let's continue here. What do? We divide everything by m. So it means we will have dx dt square plus c dx dt c over m. Remember, everything is divided by m now. Plus h over m to be equal to f of g over m. Now you have written the differential equation. Now the only reason why they're expressing this thing to be equal to this, so that when you use the Laplaces, you'll be able to solve this. And this question was actually easy. I believe it was the easiest even among all of them. We just did not get the chance to do it, but I believe that we've got an idea that during the test. But anyway, we are here. It's revision, we qualified, and we're gonna make it to exam. Now that was 2 marks. Only these 2 steps here. That's why it was 2 marks. It's a 1 minute thing. 1 minute, 2 minute noodle, Mr. Koto. Yes, they say determine the response of the system with initials. This is really, 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 really important. They want you to solve for the response function. Whenever you ask for the response function, we use Laplaces. And guys, whatever we are doing here, you did it last semester, Math 4. This question, the same question. I know you did it. But anyway, let's push. They want us to get the response function. For us to get the response function, what do? We introduce Laplace. We need to get it. What we need is to get a function of x of t as answer. For us to get it, that's what we call a response function. You need basically what you are doing, you are solving using Laplace. But before we do it, we can substitute our value to get our expression easier. So how do we do it, Zandile, Mabuza, Koto, Machimba, and Dile? We substitute the values. Dx dt square. Mr. Koso, my connection is working better after 8. I don't know why. plus, what is C over M? C is 120, unless I'm mistaken. Over M, it is 40. Okay, guys, not okay. Let's go. Let's just write step by step. And this video is being recorded. Plus HE over 40. Now, remember what they said. They say the expression f of t over m, it is basically this. So there's a reason why they are giving it to you, for you to get an easy expression that you can solve using Laplace. So this is it. Yeah. So if we have to do this and calculate dx dt square, what is 120 over 40? It's 60. Eh, what am I saying? 120 divided by 40. It's 80. What am I saying? But one thing I know, they are multiple. Are you with me, guys? I hope I'm not having a network problem. Please. It's 3. Hey, I was getting big numbers, eh? When I was saying H, I'm scared, because when you multiply back, you're like, what am I doing? This one is supposed to be 2. Mr. Machimbas, Angela, you with me, guys? Simply what I've done so far, I've just substituted our values to get our differential equation with actual values. Now, if you want to solve for the transfer function, what do? We introduce Laplace both sides. And if we remember, like I said, we have done something like this in Math 4. Plus 2 to be equal to Laplace of 2 exponential minus t. Now here's the thing, guys. We are given boundary condition, and it is really crucial, very important. These boundary conditions, they are the one that guide us through the equation on how solving this. But this is really nice. When they gave you x0, they say x0 of 0, is it x0 is equal to x prime of 0 is equal to 0. This simply means your initial conditions are 0. Okay, what does this mean? Let me open my math 3 book. When you use Laplace formulas for each and every variable, it comes with initial condition. What do I mean by that? Formula will be provided to you. If you want to get Laplace of dx dt, here is what the formula says. The formula says that, okay, you guys here, you talk about y of s. In the book of Math 3, Math 4, in VG, we talk about y bar or x bar. It doesn't matter. But we're going to keep the same writing that we are writing in vibration here, which is y of s or x of s. If it is dx dt square, this is how it shows. It says that you have s square. I'm just reading the formula. I'm taking it from my maths book. Y of s, and then what follows, they said you have s, and then you have no, why am I saying y of s? It's not y of s. Why it was, if it was dy, it's supposed to be x because we are dealing with x coordinate. So yeah, please let me erasing and write. Please, if you don't understand something, please tell me. Okay, now I'm writing, when you want to find Laplace of dx dt square, I'm just writing the formula for you to see why this formula is really crucial. In fact, when they are all zeros, it's even easier on solving the problem. Sorry, guys. Sorry about it. Yeah, what I'm gonna have here is s square y of s. This is what's happening, minus S. Oh, why am I saying Y again? I'm writing Y because on the formula here it is Y, but it's supposed to be X. Why is it X again? Let me repeat myself, because everything here is the variable of X of G. So yeah, that's the reason why we have XX. If it was a vertical system, we're supposed to talk about dy. Since it is an horizontal system, yeah, thank God now I can make the difference between vertical and horizontal. Have had a struggle for the past every year that I've been in school. So this is xs, Mr. Code. So multiply by s x0. That's what's happening. Minus here you have x prime of 0. Now, since in this our case, they say that this and this is 0, so it means we will not take in consideration this part. And guys, whenever you see all your boundary condition to be 0, do not worry about what happened next after the first expression on your formula using Laplace. That is only applicable when all your initial conditions are 0. I'm repeating myself. Only when the initial conditions are 0. So now this expression becomes very, very easy, Mr. Code. So what happened here? Since I know here, the only thing that I'll be having a Laplace of this is going to be s squared x of s. That is for this term. Plus 3. Now I will look again, the x dt. What does the formula say? That formula says it is simply, let me write it here, but this will be provided to you. It will be provided. It simply says you have s and then you have y of s, minus, guys, excuse me, I don't know why I'm writing y. I'm writing y because where I'm copying this formula, it is written y. Once again, it is x. So it's supposed to be s x of s minus x of 0. But remember, this initial condition means that it's equal to 0. So we don't worry about what is here. So what is important here, we're going to have 3s x of s plus Laplace of a constant, it is simply y of s, x of s, sorry. So this guy will be 2x of s to be equal. Now you have to solve for Laplace of this guy. Now you are also given a formula for this, Mr. Corso. Laplace of exponential. The formula says if you have exponential bt, Laplace of it is 1 over s minus b. So if we try to apply it here, forget about the constant. The constant is the constant. It is coming out. Let's apply the Laplace. It's going to be 1 divided by s. Now you have minus of the formula. Remember, your b is negative. So minus of the formula and the minus of your b gives you plus 1. Any question, guys? This is literally math. It's pure mathematics. There's no mechanics apply here or trying to study how is the movement affecting. We are simply doing the math. Now, what do we do, Mr. Krotso? What do you do next year? We can make x of s subject of the formula. We are simply solving the Laplace, guys. So it means here you have s squared plus 3s plus 2 to be equal to 2 over s plus 1. So what do? You make xs subject of the formula. So you have 2. Everything here will be s plus 1 multiplied by this guy will come down s squared plus 3s plus 2. Now we are not yet done, guys. This is x of s. If you want to write the transfer function, what you need is x of t. So what is x of t? X of t, it is simply the inverse Laplace of x of s. Literally saying you have to solve for inverse Laplace of 2 over s plus 1 divided by s squared plus 3s plus 2. This is what we meant. This is what we have to solve. Now, before we solve again, guys, any question? Mr. Costa, you've been married?
Yes, yes.
Okay, guys. We will have to balance for this preparation. So we're gonna mix vibration and what and what and what. But what I believe is we can finish this paper tomorrow, or two questions finish tomorrow, attack something else the following day. Zanjile left. Oh my goodness. Okay, guys, how do we solve this? We use partial fraction. First of all, can we factorize this one, guys?
Yes, we can.
Oh, okay. What's the factorization? It becomes easier then. What is the factorization of this? I don't know how you factorize. There's a method that I liked when, let me not say when, like I've studied long ago, no, but there's a method that I liked from my colleagues. Is I don't know how you guys do it, but it's something that I felt to understand. They used to do something this plus this, and then they find out common what, and they give you the whatever they as factorization. I don't know if that's what you are doing, Mr. Koso. What are you doing, Mr. Koso, to know that they are factorizable?
I usually do it. I usually do it with my calculator, but I don't have it now.
Oh, Mr. Machima, how do you do it, my brother? Hmm. Angela, okay. I don't know. I don't really remember how they were doing it, but what they were doing is they will say maybe this and this have to be a multiple of this, and then what they get it, and it's a nice method. But unfortunately, I failed to understand it, and yeah, it's okay. But what you can do if you want to factorize, put a quadratic equation of this. You will get value. If it gives you actual values, let's say minus 2 and 1, it means those ones are factorizable. So it simply means when you factorize them, you'll write them with opposite sign. I don't know if I'm making sense. Okay, what is the factorization of this case here, Mr. Kozo? This s plus 1, if you factorize this expression, what do we get? Let me try something here, but don't do this method here. It's very long. No, it's not long. I just personally like it. Mr. Koso, this is not factorizable because if I put,
Oh, sorry.
I don't know, but I'm just trying to see one of the way to see if this thing is factorizable. You can simply look at, uh, you substitute a value that can make everything here to be 0. We usually start with 1. If 1 doesn't work, you go minus 1. And then you go to minus 2. But you can see by the look of things, these things, it will not give a 0 somewhere. If I start with 1, I'll have 1. This everything won't be 0 if you put 1. But if you put minus 1, it will give you positive 1. Yeah, it's factorizable, Mr. Kotso. It is. If I put -1 here, I will have -1 square plus 3 times -1 plus 2. So what does it mean? It means here I'm going to have +1 -3 and then +2. Everything here gives 0. So it's factorizable. One of the factor is -1. It's crazy this method, but you don't have to do it like this. The easiest method is use your quadratic equation. You will get these factors. I just like doing this because it's something that I did in high school, and the network is gone. God. This network. Supposed to be back now. Ash. Okay, my bad, guys. Let me come back here. You're supposed to be back now. Okay. Yes. Hey, Mr. Kotso, Mr. Mabunda, Andile. Sorry, guys. This Wi-Fi does that sometimes. But we are back here. This is factorizable. You can do, like I said, use a quadratic equation. But this one I like it because it's a method that I used to do since high school, and yeah, I had to experience it with my dad. That's why I like it, and I always do it when it's. With this, I can factorize whatever, whatever polynomials that I want to. So one of the way of doing that, I can recall everything, all the guys here, 1, 3, 2, and how it works is you drop 1, but you don't have to do it like this. It's easier to use a calculator. You put the quadratic equation, you'll get these values, and then I go 1 times 1 gives me uh it gives me -1. So I add these two, it gives me 2. At the end I need to have 0, and then I have uh 2 times 1 minus 2. When I add, I have 0. So it means one of the factor here, it is s. It has to go with the inverse of this one. Minus, it's going to be s plus 1. And then the remaining, this coefficient goes with s. And then you take the last guy here, s plus 2. So if you have to factorize, you will get s plus 1 again. And then you will get s plus 2. So, funny fact here, Mr. Koso, we do have s plus 1 multiplying out here. So, under this case, we're going to be 2 s plus 1 square multiplied by s plus 2. Yeah. Now, what do we do, Mr. Grotso, to solve this? Okay. Mm, what do we do, Mr. Koso? Now I'm just thinking of something. If we can use Xavier's method of, and do you remember it, right, Mr. Koso? There is a method that you send me pictures from class, and I think we had a class about it even here. But before, we need to write
Yes, I
this.
don't remember it well.
Yeah, but I'm just picturing if we can do it like that way. There is a way that we can do it as well. But this is the partial fraction. If we want to write this in terms of partial fraction, let me say I have a over s plus 2 plus. Now, on this case, what is this one here?
Yeah, you're right, Mr. S. You're going to say plus b s plus 2 squared. I
Now,
think something like that.
but I
X
can.
plus 1, then s plus 2 squared.
Oh, now you reminded me because I was about even to say expand. No, this one is a repeated square. So it's going to be, thank you,
Yes.
Mr. Koso. It's going to be b s plus 1 and it's going to be c s plus 1 square. Thank you, Mr. Koso. Yeah, this is what is happening here. So at the end of the day, what are we doing? We need to solve for this figure, for these guys here. And literally, I'm pretty sure Xavier wanted us to use the method that he used in class. Fortunately, let me check again if I do remember it, Mr. Koso. I think I have a video on it on YouTube even. If you can check my YouTube channel, it's there on my YouTube. But I don't know what's happening. I don't, I don't want to do it the way we used to do it in in math 3 or math 2. That one is a longer way where you have to multiply factors, what. We are growing academically, so the method of solving should also grow. So I'm just checking if there is somewhere that I wrote something like this so that it will be easier for me to remember and we finish this question. Literally, the question is just finished. For you need to solve for this Laplace here. Mr. Boso. Oh,
Yes.
uh, hey, my brother. Where, where is that thing, Mr. Koso? Hey, Mr. Koso. Mm, you sent me pictures
I
about.
sent it just now. I sent it just now.
Yeah, please,
I
please.
know.
I, I just want to check it again, but we did it and it's on my YouTube channel. What was the formula again? This time wants to end. No, 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 not the formula sheet, Mr. Koso. We're gonna use this one as well. But what I'm talking about is I don't know if you wrote it down. It is something like this. The way we can solve for A easily. Let's say for B. Let's say I want to solve A here, right? Uh,
You are going to take the
yeah,
denominators of
yeah. Just
B and C, and then you're going to
no. If I want to solve A,
substitute.
I'm still using
Let,
this
let
one
me
here.
send you the notes. Let me send you the notes.
Yeah, please, please resend me, my brother. I just want a quick recap. It's gonna take a minute, but for what I know, if I want to solve A here, what I will have the limit of, let's say, s moving to minus 2. Why minus 2? Because minus 2 is the one that makes a 0. And then what will I be using? I will copy, and remember, I'm just maybe failing out to write it, but everything is being multiplied again by s plus 2. Literally, what's happening is I will not have the expression of s plus 2. I'm only going to be having 2 divided by s plus 1 square. Now, if I have to solve it, I will have 2 divided. Where there is s are replaced by minus 2 square. So this answer here is 2. So therefore, a is equal to 2. This is how we do it. Now, if I have to solve for b here, there's a formula that I want to check. That's what I'm asking you to check the note. But I'm definitely sure, 100% sure, I have solved this something like this. It is on my YouTube channel, but we're gonna do it again right now. I just need to remember how we do it. Yes, Mr. Koso, but this is how you solve for a s minus 2, because s cancel this. But I've not really remembered. It is something like this, if I remember well. Maybe by writing I will remember. It says you have 1 over n minus 1 factorial d ds Mr. Koso, okay, okay. Mr. Koso, my brother. Andile, I can't even find it on my note, but this thing is easy. But we need to
Yeah,
do it.
I also can't find it right now.
No, but we need to do it. We need to do it, Mr. Koso. Yes, yes, I think I've found it. I think I found it. The formula says yeah. This is what it says, guys. It says you have 1 over n minus 1 factorial d ds of, let's say, of what we have. Let's say it is s plus 1 in this one here. S plus d ds s plus 1, let's say square, multiply by f of s. This is what the formula is saying. Is it s plus 1?
Mr. Ice,
Yes, my brother.
don't we use this formula when we get like an error somewhere?
No, 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 no. It's not about an error somewhere.
Mm. I think last time you said something like when you can't find B,
No,
that's
no,
when
no.
we would
If I said
explain.
it last time, then I'm changing it now. What I'm saying is, uh, we are using this formula because you can see this our, how do we call it? This our, how can I call it again? Mm, how do we call it again, Mr. Cost? This our denominator, it is a s plus 1 square. One of the reason why we cannot do it straight like this one here, it is because this one here cannot cancel. It will give you 0 if you try to cancel it out, Mr. Kotso. Let's say you want to cancel s plus 1 here. Even if you cancel what am I saying? Even if you substitute here by minus 1, it gives you 0. Everything becomes 0 at the end. This will not work. I don't know if I'm making sense. It will work for s plus 2 square. Let's say you want to solve c, right? This is c. C is equal. It means you will be having lim of s moving toward what is going to be minus 1, because 1 is the one that makes this 0. Now, what happened here? You will be, oh, this connection, God. Check this thing. Shit. And this meeting is ending in 5 minutes, but let's try to do something, guys. So I don't know why this thing does that on its own. Okay, Mr. Coach, so what I was saying here, let me try to zoom in and pin here. If we want to get A and C will work. Look what's happening. For C, we can apply this thing here. C will be equal to lim. Now, will be S moving to minus 1 in such a way that if you multiply S plus 1 square, it will cancel out this guy. So what you have inside here is 2S plus 2. So if you have to solve for C here, what you'll have will be 2. You substitute S by minus 1. Minus 1 plus 2. So the answer that you have for C is 2. So you have C to be 2. Now here's the problem, Mr. Koso. If you do for B, look for B. If you bring S plus, how can I say? I mean, for b, if you bring s plus 1 on top here, multiply by 2, divided by s plus 1 square, here you have s plus 2. Okay, the reason why I'm writing like this is basically what we've been doing. You can see for C we did it cancel out, we have this. For A we did it cancel out, we have this. But for C it won't work. Why? Because when you cancel this, you still have this. And if you substitute by -1, this still gives you 0 and cancel everything. So therefore, we need to apply this formula. And that's what I said. We use this formula when we have a repeated rule, not when it is giving an error, Mr. Koto. I'm repeating myself. So now, if I want to solve for B in this case, Mr. Koto, we're still gonna go with the limb of s moving towards -1, but now it will change. Following the formula, it's going to be 1 over n minus 1. What is n? N is the power of our repeated root. So it's going to be 2 minus 1 factorial. Multiply, this one is also n minus 1. Multiply by the derivative in terms of ds, as we can see. In terms of ds, now we do it in terms of ds. Now it's supposed to be n minus 1, which is 2 minus 1. That's why it is only like this. Of now, what we do is we do it of the wall function. We copy this guy here. We copy this guy here. What is it again? We copy everything here, which is s plus Mr. Koto. Yes, we copy this guy here, s plus 1 square multiplied by s plus 2. So that's it, guys. This thing is closing in the next minute. Let me just present the link and we finish this quickly, please, guys. Let me do it now. Hey, Mr. Koso, if
Yes, Mr. Ice. So, Mr. Ice, you are getting married. I'm
no,
coming.
my brother, why is a joke? This video is recorded, my brother. It's a joke.
Hey, sorry. Hey,
No, it's a joke. I'm not getting married, but I'll tell you. Me, I was just trying to put you guys in the mood before we start the class, because you guys love marriage topics, sex nyana. Hey, Mr. Koso, if these guys are not coming, this video is recorded, so I will just continue.
let's continue. It's at night now. It's 10 o'clock.
Hmm. Okay, what I was saying, Mr. Koso, is if you have a repeated root like this, you can solve. Okay, the trick is easy. You can solve using this guy here. For the guy that can cancel out. What do I mean by that? If this is my main equation, this is 2s plus 1 square s plus 2. Do you agree that if I bring s plus 2 here, this and this cancel? Is it fine?
Yes, it's fine, my brother.
That's one of the reasons that for a you can apply this. And the limit is minus 2. We actually take the opposite of this, the number that gives this to be 0. That's one of the reasons why you can do it straight like this. You take 2 over this and you get the answer of A because it's cancelling out. I can do the same. If I put s plus 1 square here, do you agree that s plus 1 square is cancelling this? Do you see it, Mr. Koso?
Yes, Mr.
So
Ice.
it means it is applicable for C. But if I do it for B, if I put s plus 1, but here I have s plus 1 square. This is only cancelling the square. Do I still have s plus 1? Do you see what's happening? So when I substitute with minus 1, I still have a 0. It cancels everything to be 0. Do you see what's happening, my brother? Because of that, to solve for b, we are using this formula. And how does it work? It is 1n minus 1 factorial dn minus 1 ds s plus 1 square. I'm not sure if it is s plus 1 square f of s or if it is simply f of s. It is simply f of s. It is simply f of s. What do they mean by f of s, Mr. Crosso? F of s, it is simply this whole fraction here. That's why you see I've copied it here. Now, following the formula, you can type in your calculator 1, 2 minus factorial. What is the answer you type? But this gives us 1, fortunately, because 1 factorial is 1. So now, this n minus 1 here, it tells you how many times you will be differentiating. But yet again, Mr. Kotso, because under this case here, n is 2. N is the power of our repeated root. So n minus 1 simply give 1. So it means that we only gonna differentiate once here. Now, let's do the thing. We're going to have lim of s moving to minus 1. Everything here is this will give 1. Now we have differentiation d ds of the function 2s plus 1 square s plus 2. Now we have to be careful when we do this, Mr. Cross. What are we differentiating? We are differentiating only the guy involved. Basically, it's like differentiation by power. The guy involved is the guy with the power s plus 1 square. This is the guy that we will be differentiating. So this guy here will stand as a constant. So by differentiating this, I can write 2, bring this guy on top here so that I can apply the chain rule. If I bring it on top, it becomes minus 2. minus 2. So without forgetting, our s plus 2 is still here. I hope you see what's happening. I'm only differentiating this guy. Why this guy? Because this thing is acting like differentiation by part. Partial derivative. Instead of saying differentiation by part, that's the right word. Partial derivative. So now, if we apply the chain rule, knowing that u to the power n is n u prime u n minus 1. So what does it give us, my brother? Remember, you have these two which is here. If you apply that formula, Mr. Kotso, n here is minus 2. So we have minus 2. U prime, you differentiate what is inside. If you differentiate what is s, will give you 1. So it's still 1. And then you go u which is s plus 1, n minus 1. N minus 1 will give minus 2 minus 1. So we have to be careful here. We have to be careful, Mr. Kotso. So n minus 1 will give minus 2 minus 2 minus 1. This gives minus 3 over s plus 2. So if we have to rewrite it nicely, what are we going to have? We're going to have minus 4 divided. This guy can come down here as s plus 1 to the power 3 multiplied by s plus 2. I'm still, yeah. This is still not working, Mr. Kotso. Something is off. Why am I saying that? Because when I substitute minus 1 here, this still gives me 0. It's not changing anything.
No, Mr. Ice, I'll do it. I'll do it when I'm alone. But I can see, I can like,
Yeah,
what
well,
I'm trying to
because
see that I can
yeah,
see where I'll
okay.
take it from A,
The
B,
moral,
and C.
the moral of the story is you need to solve for x of t. So x of t is using the inverse Laplace of this one. For this one here, the inverse Laplace of this will give you exponential negative. Why negative? Because this one is plus, the formula says s minus b. So I can know a is 2. So I can write here, I know I will have 2 exponential minus 2t. That's for a. For c, it gives s plus 1 square. Now there's a formula for it. If you check the formula sheet that you sent, where is it, Mr. Kotso? My leader. Well, which formula is it? Okay, we have formula, yeah. The formula that say Tn exponential bt to be n factorial, and then we have pb minus 1 n plus 1. Okay, it is n plus 1. If we have to solve according to the formula, what do we get? Look, Mr. Koso, we are doing for c, right? For c, we know that c is 2. So what we are having here, it is 2 over s plus 1 square. What is the inverse Laplace of this? According to the formula says that when you have Tn exponential bt, Laplace is given as n factorial over, let's say, s minus b n plus 1. So this is where we are. Now we are moving from this to this. That's what's happening. We have, as you can see, Mr. Kotso, we do have s plus 1, which is s minus b. We do have n plus 1. Now we have to see. We do have n plus 1. because n plus 1, it is what? It is 2. So what does this mean? What does this mean? It means in this case n is 1. Now do not confuse the n that I'm talking about here and the n using this formula. Here I'm trying to match using the formula of the Laplace. They are two different things. So don't say it's 1 here and then 2 and you start mixing them, please. It's two different things. What I'm trying to do here, I'm trying to relate this formula for me to solve this inverse Laplace. So if here I have n plus 1 and I have 2, so it means n is 1. The formula says it is n factorial. So it means I will have 1 factorial on top. But 1 factorial is simply 1. So if I have to solve this, the answer says it is t to the power n. So it's going to be plus t where n is 1. Because n here in this case is 1 following this formula of the Laplace. Exponential b, but remember, if it says here s minus b, so if it is positive here, it means b is negative. So it means we're going to have minus t. This is for c, so the expression left is for b, Mr. Koso. And I'll check it for you. And provide a note about it. I will provide a clean solution and how to do it. Yes, Mr. Koso, what is next, my brother?
I hear you, Mr. Ice. No, let me go check it and then we will see.
Okay, no problem. We have to accelerate our rate of moving. We have to finish this
Yeah,
paper.
yeah, no. Because we need to do heat mass, and he says on heat mass is going to add more topics that were not part of the test and stuff. And we haven't done chapter 4 and 8, it's the ice for heat mass. You see, heat mass is the one that's stressing me.
Yeah, I can see it's stressing you. Yeah, we'll have a proper class about it. Finish the weekend.
All right, Mr. Ice.
Sure. Let me
So
send the link. No,
tomorrow, what are we pushing?
I don't know. My aim was to finish this paper because the weekend I want to sit. We do eat mass. We actually will push on where we
We are leaking, you see,
yeah.
first.
Mm,
Because vibration, you see, those first two questions,
mm,
we did them
mm,
with you
mm,
before.
mm. Now we won't waste time on that. Then we should do something else. Hey, I wanna let me close this Wi-Fi. It's gone again.